So I'd like to jump back to the topics covered in our slides. You see that we begin to talk about variables or objects in memory and doing some simple computations. So, of course, in order to be computable or accessible, we need to place an object in memory. For example, if your data is coming from user keyboard or from the database or from a file, in order to become accessible for computation, this value has to be placed with recognizable data type in computer memory. Right? So objects, generally speaking, occupy contiguous regions of memory. Objects cannot have gaps, right? So objects cannot occupy two different regions of memory. It's just one blob, one object. Variables simply provide names to objects in memory for our convenience, right? So example is this value, which is an integer, which is likely on my configuration, which is says here x86, which is a 32-bit mode. Very likely that this integer is 32-bit in size or 4 bytes in size overall. You can see that in order to create an object here, I had to specify what is the type of this object. So the syntax is simply introducing new variable into the scope of my program, and this variable is guaranteed to occupy appropriate space, and every variable in its generic term is an object. So when we specify the type, it stands on the left-hand side of the variable, and we say that the types provide the size of object and its behavior. Behavior meaning that with integer variable, I can use arithmetic operators like pluses and minuses, multiply, divide, and so forth. This statement right here is technically called a variable declaration, right? So the variable, before it can be used, has to be declared, introduced into the scope. Okay, so if you consider generic, a statement that uses some sort of computation like this, it says x equals y plus 2, overall, by looking at the statement, we don't know exactly what is x and what is y. We presume that this is some kind of values, perhaps integer values or fractional numbers that we can naturally make computations with. So for this to be valid, of course, both x and y, they must be declared, right? So declared means what? They have to be specified, and they have to be declared with their data type and with their name. Okay, so x and y are names, and double and int are data types. Double stands for double precision floating point. Okay, so once we have these declarations in place somewhere in the code, and compiler has already encountered them and understands them, then x equals y plus 2 becomes a legal statement, a valid statement. Now, we say that the overall C++ environment is strongly typed environment. Okay, so strongly typed. Let's just kind of like put this into view. Right, so C++ is a strongly typed programming language or strongly typed environment. What is the meaning of this? It means that once the variable is declared, like this int over here, it's going to be used according to its type. For example, very likely that we're not going to use 4 bytes of this int variable to store 4 characters. Very likely we're going to use this variable to store values such as 1, 2, 3, 4, 5, and whatever is the range of integer variable on the system, right? So we could use its memory with all sorts of ways, strange ways. But strongly typed programming language basically is asking us to use the type as intended and not in a strange way, right? For instance, this integer variable should not be used to store addresses of variables. For addresses of variables, we have a specific, dedicated data type, which is called a pointer. And that's the idea. And strongly typed also, of course, is the same rule is that something needs to be declared before it can be used. We discussed the idea of source files and header files in a prior lecture, but overall just a reminder, if we use an include like this, right? So I have an include that refers to standard library header IO stream, which brings into the scope these objects and some other things. So we can start using them for programming input and output. So when include is used, you can imagine that this is simply just a text manipulation facility, and you can use that. You can see that we've used this specific header file. Very likely that has includes for more header files, and these can have more includes in them. And so this process of including everything is a highly recursive process. So because I'm using a standard library header file, I am not using this stdlib facilities, which came with the textbook. But both could be used, and we can have examples of both. Let's see what else we have in our presentation here. Input and type. Input and type. Okay, let's talk about different types with respect to the input and how input facility recognizes different types. For instance, I can say include string. And if I do this, a string data type, which is a flexible string to accommodate text, can also be used. For example, since string also belongs to standard library, I continue to use standard library namespace in front of its type. Right? So string is defined inside standard library, and most of the stuff that comes from the standard library comes with this wrapping inside standard library namespace. So the full name of the string is standard library namespace : string. Okay, so now I can create something that looks like name. Right, so this is a string. When I declare it like this, string is empty. It has 0 characters, basically is not occupying any space in memory with respect to the logical string. But again, I can say something like what is your name, and print it, and then use std sin character input to populate name with something that the user types, and then I can again write another output statement and say cout. Notice the direction changes with character input and character output, right? So the direction changes this way and this way. If you misplace them, you will get a syntax error because it will say, I do not understand what you're trying to do if you misplace these. And so cout will say hello and print the name of the person, or whatever name they print, name. very likely that code like this I write for learning and debugging. So my habit is to, when I create these outputs and I really want to see the boundaries of what's being entered, I typically decorate it with some kind of, opening and closing brackets of some kind, like this square brackets that I use to just to facilitate the display and make it very, very recognizable. Let's take a look at this. So I typically build as a separate step just to see if I don't have any issues with this code. In fact, it tells me that I'm missing semicolon someplace, right? In fact, it points to the return statement, but of course the semicolon I forgot to put right here, right? So I forgot to enter semicolon. So the compiler told me that I need to redo this, and I fix my syntax error and build again. And now we can try running it.